Hello all, welcome you all to the video lecture series on social media mining. So I'll be covering the chapter network measures. So starting with the network measures, uh, we have something called as cloud. Cloud is a mobile and website app that measures users' online influence, how influential the person is on the social media. So they derive the scores of the users by incorporating a user's activity among number of social media applications like Twitter, Facebook, LinkedIn, Instagram, and etc. So cloud measures the user's social media network and correlates the activity and content posted to measure how the other users interact with that particular content. So cloud scores range from 0 to 100, and as you can see in this slide, the cloud score of Barack Obama is 99, the cloud score for Justin Bieber is 92, and the average cloud score is 40, somewhere near 40. So these measures are very difficult to find out. The process is very complicated. So we are going to find out how these measures are done in this chapter. So why do we need measures? So to know who are the central figures or influential individuals in the network, and what are the common interaction pattern between the friends, and who are the like-minded users, right? And then to find out all these things, we need to measure. We need something to quantify all these things. So we need to do the network measures. So to find out all these things, we have various options. So to find out the central figures, to find out the influential individuals, we have something called as centrality to measure. And to find out the interaction patterns, we have reciprocity, transitivity, balance, and status. To find out the like-minded users, we have similarity measures. So these are some of the measures we have to find out all these measures. So beginning with centrality, so as I said, centrality is to find out how influential the person is in the network. So how do you define centrality? Centrality defines how important a node is within a network. So each user is defined as node inside the network, and we find out that how important is this node in the network, and that's how we get the centrality score. So centrality is in terms of those who you are connected to, meaning if you want to find out centrality of your profile, so it is calculated based on all the connections that you have in your own network. So the first centrality measure that we do is degree centrality. It is the most simplest form of finding out the centrality. And how is it defined? Degree centrality ranks nodes with more connections higher in terms of centrality. Very simple. If you have high number of friends, you have highest degree centrality rank. So as simple as that. If a person has 10 friends and the person B has 100 friends, then obviously the person B has the highest centrality. So CD of Vi, meaning the centrality, degree centrality of node Vi is Di. Di refers to the all the nodes that it is connected to. Di is the degree or number of friends for node Vi. So in this graph, undirected graph, the degree centrality of node V1 is 8, because V1 is connected to V2, V3, V4 up till V9, and it is an undirected graph. So we will say the degree centrality of node V1 is 8, and for all other nodes in the graph, that is from V2 to V9, the degree centrality is 1, because they are all just connected to V1. So in directed graph we can use the terms in degree and out degree and combination of in degree and out degree to find out the degree centrality value. So in degree is defined as CDVI di of in, and it is also called as prestige of the node, and out degree is also called as gregariousness of the node, and combination of this will give us the total degrees that the node has. It is same as I had defined it in the previous slide. So D out gives us the number of outgoing links for node Vi. So these degrees has to be normalized to some possible degree, right? So we have three formulations to do the normalization of degree centrality. The first one is where we divide the number of connections with n minus 1. N minus 1 is number of nodes, n is number of nodes subtracted by 1. The other way of normalizing is CD max of Vi is equal to Di divided by maximum degree that we have. We divide the Di value with Dj, and the third way is to divide the Di value with summation of all the other degrees in the network. So we have an example here of the directed graph. We have 7 nodes in the network starting from A, B, C, D, E, F, G. So each node has some in degree and some out degree. So as you can see, node A has in degree of 1 and out degree of 3. B has in degree of 1 and out degree of 2, and so on till G, where it has in degree of 2 and out degree of 1. So how do we calculate centrality of these nodes? So as I said, the centrality is calculated by using Di divided by n minus 1. So here if you see for node A, we divide the out degree of the node, right? Since node A has 3 out degrees, we divide this out degree value 3 divided by n minus 1. So what is n here? N is number of nodes that we have. So the number of nodes that we have here is 7. So 3 divided by 7 minus 1 will give us 1 by 2. So that is the centrality of node A. Similarly, the degree centrality of node B is 2 divided by 6. So that will give us 1 by 3. So in the same way, in the similar way, we will calculate centrality of all the nodes that we have in the graph, and based on the values we will rank them. The highest value will have the highest rank. As you can see, the node A and C has the highest rank of 1, right? And then everything else has the lower ranks. So here you can say that node A and node C are the most influential nodes in the graph. So this is how we calculate the degree centrality in the directed graph. Let's see how we do it in the undirected graph. So since there is no direction here, we take the whole degree, right? So and we calculate centrality in the similar way. Degree divided by n minus 1, so it is 6 in this case, and similarly based on the values, the highest value will get the highest rank. And then see, in the previous slide, in the directed graph, we had A as the highest ranking node, whereas here in undirected graph we have C as the highest ranking node. So this is how you calculate degree centrality.